This is Unit 2, Lesson 5, Part 1. The topic, as you can see right here, is solving equations or solving systems of equations by using elimination. So there is a series of 5 steps right here. What I'm going to do is walk through equation number 2 while we're looking at these steps. So step number 1, and we won't have to do every step every time, but I'm still going to kind of explain what each one means. So step number 1, line up the equations. What that means is you want the x's right on top of each other on the left side, the y's right on top of each other on the left side, then the equal sign, and then the constants over here. So step 1 here is done. You can see that everything is perfectly lined up. Everything on this page is actually perfectly lined up. It's when we get to the next page that we'll have to do a little bit of rearranging perhaps. So just to show you something like 7 or 8 on the next page where the order isn't in this standard form like they all are on the first page. That's when you'll have to do step 1. Step 2, multiply one or both equations by a number to result in a variable with the same coefficient. Okay, so same coefficient, we're gonna add a little note in here. So the same coefficient with opposite signs. That's what we want. We want the same coefficient with opposite signs. So if you look at number 2, we have a 3x and a 5x. We would have to turn those both into 15s. So let's look at the y's. We have a 2y and a negative 2y, which is actually exactly what we want in step 2. So we didn't even need to do that step either. We already have a positive 2y and a negative 2y, which is the variable with the same coefficient but opposite signs. So we're good on step 2. So step 3, we're going to say we just want to add. Thinking about subtraction makes it too confusing because people tend to mess up negative signs. So we're just going to add the equations to eliminate this variable. So here's where we finally get started on number 2. So we add the equations together, and that just means combining like terms. So we combine up the 3x and the 5x, and that gives us 8x. Combine the positive 2y with the negative 2y, and that's why we call this the elimination method, because those end up canceling each other out. And that's why in step 2, we needed to get the same coefficient with opposite signs so that they would cancel out. Equals, and then I add these two things together, and this gives me 64. 22 plus 42 is 64. So we did that. That's step 3. Step 4, solve for the remaining variable. So usually this is just a quick division problem like this one. So the remaining variable is x, and to solve for x, we're going to divide both sides by 8. So divide the left-hand side by 8, and on the right, 64 divided by 8 leaves us with 8. So that's step 4, and then finally step 5, substitute your answer into step 4 into either original equation to find the other variable. So now we know what x is, we can use that to find y. So you can pick either one of the equations. Maybe one of them looks like it has lower numbers. Maybe you just always want to go with the first one. Literally does not matter. So I'm just going to go with the first one. So 3x, that's where the 8 gets plugged in, plus, whoops, hand slipped there, plus 2y is equal to 22. All right, so 3 times 8 is 24, plus 2 times y is equal to 22. So to solve for y, I'm going to subtract 24 from both sides. So that leaves me with a 2y. And then 22 minus 24 is a negative 2. I'm going to sneak this in here, divide both sides by 2. So this leaves me with just a y. And when I divide this side by 2, I'm left with a negative 1. So I have an x coordinate and a y coordinate. So identifying the solution, make sure that you're putting it as an ordered pair. So my ordered pair would be 8 for x and then negative 1 for y. It is called an ordered pair for a reason, so make sure that it ends up in the proper order when you're done. So this is your answer for number 2. All right, so we're going to kind of zigzag around the page here. Let's take a look at number 3. Number 3 is not quite as easy. We're going to follow the same 5 steps. Line up the equations. You can see we've got x, y equals number, so that's good. Step 2, multiply one or both equations by something. So if we look here, we have 4x and an x. This is a negative 9 and a positive 5. So our goal is to kind of make this process as simple as possible. If we can make it so that we only need to multiply one equation, that's what you want to do. So since this is a positive 4, we could turn this into a negative 4 without having to change this one. All right, so I'm going to take this whole bottom equation. I'm going to multiply everything by a negative 4. And that way this will be a positive 4x and this will be a negative 4x. So let's rewrite these. So top one, didn't have to make any changes there. I was able to just keep it the same. Bottom one, if I multiply by a negative 4, I have a negative 4x. My next term would end up being negative 20y equals, and then negative 4 times 4 is a negative 16. So that was step 2. I multiplied, so now I have these opposite coefficients right here with the x's. Step 3, add the equations to eliminate this variable. So I'm going to add these two equations together. That'll make the x's eliminate. This will leave me with a negative 29y is equal to, and then I add these together and I get a negative 58. So that was step 3. I added the two equations together. Step 4, solve for the remaining variable. So I'm going to solve for y. I'm going to do that by dividing both sides by a negative 29. So divide this by a negative 29. And then this actually comes out evenly. I don't know how familiar we are with these numbers, but negative 58 divided by negative 29 comes out to be 2, positive 2. So we have y now, and then last step is to substitute that into either equation to find the other variable. So I'm going to go into this equation because the x is already by itself, so that'll be just, one step easier when we're solving for x. So x plus 5y, so that's where I sub in the 2 for y, is equal to 4. So this, I have x plus 10 is equal to 4. And then I can solve for x by subtracting 10 from both sides. So 4 minus 10 is a negative 6. So final answer, you want to put it in an ordered pair. And remember, the word ordered means that the x coordinate has to go first, and then the y coordinate has to go second. So that's what our answer would be for number 3. Okay, so we saw one now. We had to do step 2. If we look at number 6, this one, they are all lined up, so step 1 is good. Step 2, this is the first time we're going to have to multiply both equations because 3 and 4, you can't turn 3 into a 4. 9 and 12, you can't turn 9 into a 12. So we're going to have to multiply both of the equations. So let's stick with the smaller numbers just to make things a little simpler. So 3 and 4, the lowest thing that they have in common is a 12. So I can multiply them both so that they both turn into a 12. And we want one positive 12, one negative 12. So let's take this top one, multiply everything by 4. So that'll turn the top one into a positive 12x. And then the 4x, if I multiply that by a negative 3, I can turn that into a negative 12x. So by choosing what I'm multiplying by, I'm going to turn this into a positive 12x, turn this into a negative 12x, and then I'll be able to solve my equation. So multiply everything in the top by 4, so that gives me 12x minus 36y is equal to 36. Bottom one, multiply everything by a negative 3, and always be careful with your signs when you do that, because like if you're multiplying a negative times a negative, you need to make sure that you make that positive, different things like that. So multiply by a negative 3. So negative 3 times negative 12y is a positive 36y equals, and then on the right-hand side, negative 3 times 36 is negative 108. Okay, so that we had to do something a little bit more complicated. This is the first time we had to multiply both equations by a multiplier. So now we're into step 3, add the equations to eliminate the variable. So we add the equations together. 12x minus 12x eliminates, which is what we wanted to happen. But then notice here, the negative 36y and the positive 36y also eliminate. So I have absolutely nothing left on the left-hand side of my equation. No x's, no y's, like literally nothing. And then on the right-hand side of my equation, when I combine those numbers up, I get 36 minus 108. And that, just typing this in, is negative 72. So I got 0 on the left-hand side. I got negative 72 on the right-hand side. That's not true, obviously. 0 is not equal to negative 72. So sometimes all of your variables cancel, and one of two things will happen. This is a false statement, obviously, right? So this, 0 is not equal to negative 72. So when all of your variables cancel and what you end up with is a false statement, the conclusion that you would make for your final answer is that there is no solution. Okay, so we're not going to see this in the notes, but if everything ends up canceling out and you end up with like 4 equals 4, like something that is true, if it's a true statement, then this is where you would say infinite solutions. And we saw both of these options when we were solving by graphing. So no solution means if you were to graph these two lines, they would be parallel to each other. So that's why there's no solution, is because they're parallel and they don't ever cross. All right, we're gonna look at one more on the next page, number 7, which I pointed out earlier. So this is the first time that we need to do step number 1. So step number 1 says that we need to line everything up. Excuse me. So this x needs to be on the other side of the equation. So I'm gonna subtract 2x that it ends up over on the left and combine that with the 7y, and then that leaves my 8 over on the right-hand side. So this is just the second equation. So I'm gonna scratch this, replace it with this. So I just did a little bit of rearranging for step 1 so that everything was lined up properly. So now I have x's, y's equals numbers. So now we move on to step 2, when we need to multiply by something. So for 5 and 2, I can make those into 10, and 6 and 7, I can make those into 42. Obviously 10 is smaller than 42, so I would go with that. Total personal preference though. So let's take this one. This one's already a positive 5, so if I multiply by 2, this will turn into a positive 10x. And then this one's already negative, so I just need to multiply 5, and it'll be a negative 10x. They already had opposite signs. I just had to worry about giving them the same coefficient. So let's rewrite. So multiply everything in the top by 2. Looks like that. Multiply everything in this bottom equation by 5. Now it looks like that. So that's my new system that I'm working with. I have these opposite coefficients on the x's. So now next step is that I add them together. These will eliminate. Then I have a negative 12 and a positive 35 for y, which would be 23. And then 6 and 40 would be 46. So I got one variable now, just a y. So my next step, step 4, says I'm supposed to solve for the remaining variable. And I do that by dividing both sides by 23. So this is just a y. And on the right, 46 divided by 23 is 2. So that's my y value. And my last step, step 5, says to sub that into either equation to find the other variable. So I'll just go with the top equation. So 5x, trying to solve for x, minus 6 times y, that's where the 2 gets subbed in, is equal to 3. So solving for that, we have 5x minus 12 is equal to 3. And then next thing I do is add 12 to both sides. So I get 5x by itself. 3 plus 12 is 15. And last step, to solve for x, I would divide both sides by 5. So 15 divided by 5 is 3. So make sure your answer is written in an ordered pair, if it is an answer, which is different from like number 6. So ordered pair means the x coordinate first, and then the y coordinate, and that would be your final answer.